contain the data with the same value for the attributes. So what we do is, in decision tree, what it does is, all the roots, all the attributes are considered as the root. Then we calculate for information gain, entropy, then gain is calculated, and the highest value of gain is kept as the root tree. And then that particular root tree attribute subset is made as the branch node. And these two steps keep on continuing until we reach the leaf nodes. So this is just a simple way of saying. So there are some, for calculating this, we have this information gain formula, then entropy, then gain are calculated. So I'll show you a brief. So suppose in Weka, this is the data taken from Weka. So we have five attributes, right? So we have 5 attributes. We have outlook, temperature, humidity, and wind. And play is used as a class. It is also known as a class classifier. So suppose the outlook is sunny and the temperature is hot, and if the humidity is high, and if it is not windy, then he or she can play. So whether, depending on the weather forecast, whether he or she can play or not. So this play is also known as, this attribute is also known as classifier. So here we have 14 instances and 5 attributes. Class is play. So under play we have 5 no and 9 yeses. So first we calculate the information gain. The classifier is a play, no? So we have 5 no. 1, 2, 3, 4, 5 no, and 9 yeses. So just we plug into the formula of information gain, then calculate the log base 2. This is 9 is no, 9 is yes, and 14 is the 14 attributes. Then just plug in, then we have an information gain approximately 0.940. So first step, we are calculating the information gain for class play. Then other attributes we have, right? Outlook, temperature, humidity, and windy. So we are going to calculate for this. So we go for calculation of this. Under this outlook, we have sunny. Then we have also overcast. Then we have rainy. So, yeah. I mean, yeah, we have attributes. First, we are going for this calculation of information gain of class play. It is used as a classifier. So then we are going for entropy. So we are in next step, we are calculating in the same way, like we are calculating for entropy of outlook, sunny, we are calculating the entropy of outlook, temperature, humidity, windy. So we just plug in we just calculate the entropy of outlook. This is the entropy outlook. Suppose here is sunny, we have 2 years and 3 no, and this is the information gain for sunny, overcast, rainy. In the same way, we we plug into the entropy outlook for outlook. This is for outlook, okay? So 0.692. Then gain is information gain minus entropy of outlook. This is 0.940 is the information gain from the class. Previously, this is the one, information gain. So 0.940 minus outlook, entropy outlook, 0.692 equal to 0.248. This is the gain of outlook. In the same way, we calculate for temperature, humidity, windy. So I'm not going into the details, just I'm showing you. First, we calculate the information gain, then we go to the entropy of different attributes, then calculate the gain. So we have gain for information gain outlook is 0.248, then for temperature 0.029, then humidity, then windy. This is supposed to be windy. So we are taking the highest value. So gain is highest for the attribute outlook. So we are taking the gain. So we are taking the outlook attribute as the root node. So we are taking as the outlook as the root nodes. Then the subset of outlook is sunny, overcast, rainy. So in the same way, we are going to calculate the information gain for sunny and information gain, entropy, and gain for under sunny, overcast, and rainy. So under sunny, we have 3 no and play 3 no and 2 yeses. So in the same way, we are going to calculate under the sunny for entropy of temperature, humidity, windy. So we have under temperature, hot, mild, cold. So we are just calculating the information gain, entropy of sunny, entropy of humidity, and entropy of windy. So in the same way we are calculating, then we are getting the gain. So gain, humidity is the highest. So the branches of sunny will be under sunny, it will come humidity. So humidity, under humidity, we have high. We have two subset, high and normal. Under high and normal, we have yes or no. So if it is high, it is only no, and if it is normal, then yes. So that is the end of the leaf node. So we got the leaf node, right? Leaf. So then we'll go to the next attributes of a subset of under overcast. Then under overcast, we have only yeses. So we got the leaf nodes. Then next we have rainy. Under rainy, still see humidity attributes is already kept here, right? So we have a left one is temperature and windy. So we'll calculate for this in the same way, entropy and gain. So if we calculate the information gain and entropy and gain, we got the windy as higher value. So we'll be placing under this rainy as windy. So under windy, we have two subset, true or false. So false, true, and under all the true are no, and all the false are yes. So we got the leaf node. That is how the tree are constructed. So what it does is first they are calculating the information gain, then calculating the entropy, then calculating the gain. So the highest gain value is kept as a node. This as a node. So in Weka, what you can do is load the data. Then you can, under this tree, you have J48, that is a decision tree. Then you have random forest, random tree. You can visualize it. You can see it too. Just I'm showing you like in the background what's going on. What are the calculation for creating a decision tree? So information gain is calculated, then entropy, then gain, and the highest gain value is kept as a root node. In the same way, the subset of that particular attributes is also calculated, and that step keep on repeating unless and until we got there, we get the leaf nodes. So I'll just show you. I'll just show you in Weka. Wait, okay. You can see my screen, right?
Yes, sir. Yes, sir.
So I'll just load the data. So I'll just say weather nominal, open it. Then for classification, go to classify tab. See here, you can see that the data we have Outlook. We have three, under Outlook, we have three categories: sunny, overcast, rainy. Then we have under temperature, hot, mild, cold, then humidity, then wind, and display is used for classifying whether he or she can play under such weather condition. So we'll go for classifier, go to classify step, tab, then you go to tree and tree. Then this J48 is also a decision tree algorithm. I'll just give default cross validation fault as 10. This cross validation fault, then what is cross validation fault? This will be explained by our Surya, okay, Sir Surya. So he will be explaining in this class, or I don't know whether he'll explain on this class or next class. So while taking SVM, he will tell. So I'll just set, I'll use just the default value start. So here are the correctly classified instances, incorrectly classified instances. So this is the confusion matrix. Then we'll just visualize the tree. Just right click on it, visualize the tree. Then this is the decision tree. If it is Outlook is kept as the root node, then under root node, under Outlook, we have subset of sunny, overcast, rainy. Then under sunny, if it is humid, humidity is high, then he or she can play. If humidity is normal, yes, he can play. And if it is overcast, yes, he can play. And if it is rainy, and if it is windy, then no, he or she can't play. And if it is windy, false, windy, no, then he or she can play. So that's just basically there is nothing much in here. You can also try out in R also regarding this decision tree. So like, you guys have R or not? You have R classes?
Yes, sir, you only taught.
Oh. Sure. So what you can do is you can check out the packets like Caret, Play, Tree. You can also try out in R. So, like, any question?
So can we implement this tree for absolute values? Like this is nominal values where there are, for example, in temperature we have given high or low.
Yeah, you
But
can do.
what if the temperature is 20 degree, 30 degrees? So we like that we can, in that we can classify below 30 we are considering, below 25 we are considering cold, and above that like mild, and then hot.
Yeah, you
So
can
like,
carry out the numeric value also. For just an example, so it's easier for categorical values. So I'm just showing you the one.
yes,
In
like
category.
it can be used in that values, right? Also.
Yes. Even in R, I think you can set also like, see, you can set some. Here we have a class classifier, right? Like play, whether he or she can play. So some data set people uses this one also, like they can assign the class classifier of attributes. Suppose like depending on the attribute also they can assign and classify. You
Yes.
can carry out in numeric also. Here though, it's like what? This one Veka, this one is, it's like graphical user interface now. So just we are just introducing to what is decision tree and decision tree, how it is done, background. So just a demonstration of it. Like you have to explore. You can carry out in Python, R also, and packages. You can load your own data, then set You can make it as a training set, then you can load test data, then you can also check out for this one, how many misclassified those things, and you can check for this confusion matrix, create a confusion matrix, then how many are misclassified and classified. So in this decision tree, generally it gives low prediction accuracy uh, compared to other machine learning. So, and it becomes like the calculation become complex now when the class level is so many. So, and is it can give also a biased response for the attribute with if they have so many categories now. So, and probability of overfitting is very high in decision tree also. Surya is not there now. He is supposed to take SVM today. So you have only that class, right? In second semester, that R class
Yes, sir.
regarding R. So okay. Uh, any other question? Like, did I answer your question? Like, if
Yes, sir.
not,
Got it.
then
Yeah, yeah. Sir, actually, I was thinking like if we are like here in Weka, we are using the dataset present over here, but if we are using for external data, then whether we can use decision tree as an application for classifying those.
in Veka also you can load your local data, no? CSV file format also. It supports.
Yes, sir. Sir, actually, the data set I have, like, I can't download it. I have to take the screenshots. So that's why.
Or you can't download it.
No, sir.
Means like from where you are trying to take the data.
Yes, it's like from some site. It's asking me to create a account or something. So that's why.
Okay. What you can do is now, if you want to learn, CatGirl, the website, there also so many example data will be there. You can create account and you can try out if you are interested. I'll share the link in the chat box here, catgirl.com. So you can try out so many data set will be there, and you can even submit the result, your result.
Yes, sir. Actually, I have like the data set I was talking about. I got from Kaggle only. I don't know whether it's secure one to create an account or something. That's why they are asking me to use Google account to like link to in order to download it. So that's why.
Okay. You can just make your own data also, not like randomly, like how it is classifying, just to check.
Yes, sir. Got it, sir.
Yeah. Any other question? It's like just wait for a while, okay? I'll call him. He will demonstrate SVM, support vector machine. It's a part of classification. Okay, I think he's not available today, so he'll take class in next class. Next class, he'll be taking SVM, then all those regarding cross validation, he'll be teaching you. Then Rajesh, he'll be taking class on this clustering. So, yeah.
Sir,
Yes,
sir, what about record?
record. Yeah, you try to maintain it like means like you try to maintain it. Like today, we have taken decision tree, né? So just write like what are the theory behind it. Then we just try to.
We can take any data set from the sample data set, no, sir?
Yeah, you can take from that. All the data is available in Weka when you install, right? So just you put the step and just screenshot and put it in a Word format. Né? If man may ask you the record, so you better keep prepared. So keep it as a Word format. Then you keep it as a screenshot of those Weka steps which you have done. Né?
Okay, sir.
Yeah, you make it as in Word document format, like experiment 1, 2, like that. So people, because that's also, I think they maintain, I'm not sure.
Sir, could you please send the titles for the exercise titles?
Today one, just today we did classification rule. Just, okay. I'll type here in this chat box. It's okay, nah?
Yes,
Right.
sir.
Classification. Or you can write the classification. Classification. So what you can do is, under that you can write like aim of the experiment, then decision tree, and regarding this J48 algorithm, then step to create tree in Weka. Né? Then you can also write then screenshot of those. That's all. Then classification and the result you can put. Yeah, you better prepare the Word document for this class also.
Actually, some topics are given in syllabus. That's my thing. Can we follow that?
Yeah, you can follow.
Like introduction, data pre-processing on data set. That was the first class. So
Okay. Yeah, you can. What you do is you start from pre-processing. You write
yes, sir.
one
So
on
that would be
one on.
exercise one.
You write one on data pre-processing in Weka, right? One. You keep it as a one exercise. Then you keep it as a one as feature selection using filter method or he taught you filter method, right? Wrapper method.
Yes, sir.
So what you do is first data pre-processing in Weka 1. Second, you write feature selection using filter method. Then third, you keep it as a feature selection using wrapper method. Then fourth, you keep it as a association rule, Pyre algorithm.
Yes, sir.
Then today,
Today's is 5th, no, sir.
yeah, today one you keep it as a classification on this J48 algorithm. Then next will come classification algorithm in SVM. Then next is clustering. Keep it like that. Pre-processing, feature selection by filter method, feature selection, wrapper method, a Pyre algorithm, then classification on J48, then classification SVM, then clustering. Last will be clustering, yes. We keep it different exercises.
Okay, sir. So up to now, there are 5 exercises to be done, right?
After now,
No, up to now, actually.
yeah, now we have pre-processing, feature selection, 2 Idena, you keep it as 2. Then Pyre algorithm, you keep 1, 3, 4, 4, then J48, 5, yeah.
Okay, sir.
Okay, we'll end the meeting then.
Okay, sir. Thank you, sir.
Okay.